The concept of having only 4 Bicon implants for the support of a fixed full-arch, non-metallic prosthesis with TRINIA, a CAD/CAM fiber-reinforced resin, was first used in 2010. It has been enjoying remarkable clinical success, not only because of TRINIA's inherent mechanical and clinical properties, but also because of the clinical capabilities of Bicon's 360 degrees of universal abutment positioning, which provides the opportunity to use the TRINIA prosthesis to orient and seat the abutments in the well of the implants. The TRINIA framework may be covered with either customized polyceramic indirect composite material or by conventional denture teeth and resin. Regardless of which type of material will ultimately be used to cover the TRINIA framework, it is essential to have an anterior diagnostic positioning, wax rim, or arrangement of the intended teeth prior to the fabrication of the TRINIA CAD/CAM framework. The sequence of the following protocol steps may be altered depending on a given clinical situation. Moreover, alternative scanning procedures may be implemented. Clinically, the treatment begins with an implant level impression by inserting with only finger pressure a red, blue, or green impression post with its corresponding acrylic sleeve into the respective 2 mm, 2.5 mm, or 3 mm implant well, prior to recording their position by making an implant level impression with any convention impression material. Upon removal of the full arch impression, remove the red, blue, or green impression posts from the implant wells and insert them into an implant analog of the same color, prior to inserting them into their corresponding acrylic sleeves within the impression. Prior to the pouring of a stone model, a resilient acrylic is applied around the impression post to simulate a soft tissue contour in the stone model. The stone model is either used for the fabrication of a wax rim, or if a bite registration had already been made, it is articulated with its corresponding stone model. After articulation of the models, appropriate abutments with the largest practical hemispherical base are selected and inserted into their corresponding implant analogs within the stone model. Their prosthetic posts are then milled parallel to one another. The model with the milled abutments is used to fabricate a light-cured resin bar and denture tooth setup for an intraoral conformation of the arranged teeth. Once the denture setup has been clinically approved, a facial occlusal silicone mask is initially formed over the denture wax setup. Prior to forming the lingual silicone mask, indexing or alignment grooves are placed in the facial occlusal mask. After fabrication of the lingual mask, grooves are cut into the stone model to prevent the subsequent entrapment of air when acrylic is poured into the silicone flask through anterior cutaway or aperture in the lingual mask. Prior to the removal of the wax denture tooth setup from the stone model, the facial lingual extent of the wax denture tooth setup on the alveolar ridge is marked on the stone model with a pencil. After the removal of the denture teeth and wax from the resin bar, the teeth are cleaned and lingually roughened or modified prior to being facially glued to the facial occlusal silicone mask with a cyanoacrylate glue. An uneven, thin application of clear resin is then applied to the cervical area of the teeth on the mask to achieve an aesthetic stratification of the gingival denture resin. The facial occlusal mask and the resin bar are then repositioned on the model to confirm the appropriateness of their contours relative to each other, and particularly to the cervical gingival area of the intended teeth. If necessary, the resin bar may be modified by adding wax or by reducing it with a burr. Prior to its being sprayed and digitally scanned, the space between the resin bar and the ridge area between the pencil lines on the model is filled with a putty material so that the milled framework will be in contact with the soft tissue of the edentulous ridge. After the model with the milled abutments and the resin bar are separately sprayed and scanned, the TRINIA fiber resin bar is designed digitally on the computer with 7 mm of thickness throughout, with an abutment clearance of 30 microns for cement, and with a maximum cantilever extension of 21 mm. If necessary, the milled TRINIA framework may be judiciously reduced manually. After cleaning the milled TRINIA framework with alcohol, it is placed onto the milled abutments to evaluate and, if necessary, modify the marginal adaptation of the framework to the abutments and to the alveolar ridge of the model. The ridge side of the framework should be convex without any concavities. Additionally, the TRINIA framework is used to confirm both the path of insertion of the prosthesis in the sequence of insertion of the milled abutments on the model. After the sequence and path of insertion are confirmed, the facial occlusal and lingual mask are repositioned on the model and attached together with cyanoacrylate glue. A thin mix of denture resin is poured into the silicone flask through the anterior cutaway or aperture in the lingual mask. Final polymerization of the resin is achieved while the silicone flask and models are under hot water with 3 bars of air pressure. After polymerization, the TRINIA prosthesis is removed from its silicone flask and finished and polished in a conventional manner. After removal of the temporary abutments from the implant wells, at least initially, 2 milled abutments are incompletely inserted into the prosthesis and, if necessary, stabilized with an application of Vaseline prior to their being transported to the mouth and inserted into the well of their implant. Once the abutments are initially seated, the prosthesis is removed for the definitive seating by tapping directly onto the titanium abutment. This seating process is continued until all the abutments have been definitively seated. Alternatively, an abutment may be loosely seated initially in the well of the implant prior to the prosthesis being used to orient and seat the abutments in the well of the implant. Final or temporary cementation is achieved by first applying Vaseline over the ridge area of the prosthesis to facilitate the removal of any extraneous cement. Only minimal cement is applied to the bores in the TRINIA prosthesis prior to inserting the prosthesis in the mouth. The extraneous cement is simply blown away with the application of air under the prosthesis. The occlusion is evaluated and adjusted if necessary. Hopefully, this presentation will facilitate your providing quality care for your patients. Thank you for having watched.